Hello ladies and gentlemen, so today we're going to look at exponential growth and decay, some real life applications that you might see for this. What you're going to want to have on you, guided notes, a pen or a pencil, and then you're going to also want a calculator to see where I'm getting some of these numbers. As you can see, we're going to talk about money today, one in particular, compound interest. Now you've probably heard of this before. This is pretty much the most common thing ever. So this is compound interest when you have a model that's not compounding yearly. So this would be either a monthly or semi-annually or quarterly. So here's your formula that you're going to want to have. You're going to want to have this formula right here. And P is the initial amount deposited. So that's the initial amount you're going to put into your account. Interest rate expressed as a decimal. Now, make sure you underline or highlight that. To express it as a decimal, you can either move decimal 2 to the left, places to the left, excuse me, or divide by 100. Okay, so that's two options for you to be able to get that decimal thing. Number of times compounded per year. So we need to actually know what this n has to equal. So if it's semi-annually, it's going to compound twice a year. So it's compounding twice in the years. Quarterly is quarter, 4 times a year. Monthly, 12 months in the year, right? Weekly is 52. And daily, 365. T is the number of years, you're going to leave it in there, and A is the balance after your T number of years, after you've let the money grow. So let's take a look at an actual example of this. So I'm going to deposit $2,900 in an account that has a 3.5% annual interest. I need to find the balance after 2 years if the interest is compounded monthly and weekly. So I'm going to have two different problems. So let's do my first problem of monthly. So up here, I'm just going to put my formula here. A equals, we're going to say that's P. P times 1 plus R over N to the N times T. So I don't know my A. I do know my principal, however. My principal is $2,900. Times 1 plus my rate, or my interest rate, 3.5%. So that's my R right here. But I need to express that R using a decimal. So I'm going to move it twice to the left. I'm going to get 0.035 divided by my N, which is the number of times compounded. So I'm going to compound monthly. So monthly, if you look back there at your last note, that was 12 times a year. And then N times T. So N is 12 again. These should always match. Times your time. Your time is 2 years. I know the inside here is 2,900 times 1.003 to the 12 times 2. That's just a fancy way of writing 2,900 to the 1.003 to the 24, right? Your final answer should be somewhere in the ballpark of $3,109.96. Now, try to keep a running in your calculator. Don't just do one part. If you can, try to put it all in. Otherwise, you will lose dollars and cents on these problems. So let's do number 2 here. They say weekly, so I need to change my formula just a tad bit. So I'm going to have 2,900, 1 plus 0.035, all over, not 12 this time because I'm talking weekly. Weekly for my N was 52. 52 weeks in a year. 52 times my number of years, 2. So if you put that into your calculator, kind of do the math I did over here, you should get $3,000, 110.20. Ultimately, that's how much you should get. So, exponential growth models in real life. A lot of things exponentially grow in real life. This is how you're going to model it. So you're going to have y equals your initial amount. This is your initial, so your principal, if you want to think of it that way. 1 plus r. Notice how r is your increase expressed as a decimal. So don't forget about that decimal. To the t, time. So 1r is your growth factor now. Kind of like when b used to be our growth factor, we're going to have 1 plus r be our growth factor. So let's look at an example here. Population. So my initial population of 38 buffalo in a state park. The population is going to grow by 7% each decade. Write an exponential growth model and estimate how many buffalo are in the park after 70 years. So, each decade. First thing I'm going to need to do, y equals a 1 plus r to the t. So now, let's plug in, let's find our model. Y equals 38. 1 plus 0.07, that's my rate, times my time. Now notice, it's 0.7 for each decade. Alright? So, we are going to need to make sure our time is in decades next time. So we're going to have the t there. So we have 38, 1.07 t. So now, what we're going to do is we're going to plug in that 70 years. Keep in mind though, we're thinking about decades. So we're going to have y equals 38, 1.07. Now, t, a lot of us are going to think, well, we're going to put 70 there. No, because 7% is for a decade. Decades are 10 years long. So actually you're going to have 7 there. Because you're talking about 7 decades. 70 years is 7 decades, alright? So if you plug that into your calculator, you will get 61 buffalo. So it's not growing too much, but that kind of makes sense, right? 7% each decade, that's not a whole lot growing. So 61 buffalo after our 70 years. Here's some exponential decay model. So A is your initial amount again. 1 minus r to the t. Notice how it's minus for decay. Okay? That's a big thing to watch for. And t is your time. 1 minus r, that's your decay factor. Just kind of like b used to be our decay factor. 1 minus r is going to be decay now. Depreciation of a car. You've heard the car drops in value every year you own it, right? So let's figure out. I have a new car, and he's going to cost $25,000. And each year that I have this car, it's going to decrease in value by 23.5%, which is not actually that much. So let's figure out this model. So I have y equals a to the 1 minus r to the t. So let's figure out our a. My a is my initial cost of buying this. So that was $25,000. Right there. 1 minus my rate, which is 23.5, so 0.235, and it's going to be to the t. There we go. So now, let's plug in our 4 years for our values. So y equals 25,000, 1 minus 0.235, to the 4 years, because they're talking each year. So kind of be careful of that. Watch for that. So that should get us 25,000, and inside there we have 0.765 to the 4th. Once you put that into your calculator, you will get a grand total of $8,562.21. Notice how much your car dropped only in 4 years. I am under half the value of my car already. So there's a lot of money going away from me. And that's the end of the video. See you later.